Have you ever looked at one of these little black and white squares and wondered what's going on? They're everywhere, from restaurant menus to concert tickets. You point your phone at it and instantly, a website opens or you're connected to Wi-Fi. It feels like magic, but it's actually a brilliant piece of engineering. Imagine you're at a cafe. Instead of a paper menu, there's a small QR code on the table. You scan it, and the full menu appears on your screen. Or think about boarding a plane. The airline sends a QR code to your phone. It's your digital boarding pass, holding all your flight details. Even setting up a new device at home might ask you to scan a code to connect to your Wi-Fi network, saving you from typing a long, complicated password. In all these moments, a simple-looking pattern is communicating a huge amount of information to your phone in a fraction of a second. How does it do that? First, let's learn its real name. QR stands for Quick Response. It was designed to be read much faster than the old-school barcodes you see on grocery items. A traditional barcode is one-dimensional. It's just a series of vertical lines, and information is stored in a single direction, from left to right. A QR code, however, is two-dimensional. It uses a grid of squares to store information, both horizontally and vertically. This simple change allows it to hold hundreds of times more data. The pattern might look random, but every part of it has a specific job. It's a language that your phone's camera was taught to read. Let's start with the most obvious features. The three large squares in the corners. These are called position markers. Their job is to shout to your phone's camera, "Hey, I'm a QR code!" They also tell the camera exactly how the code is oriented. This is why you can scan a QR code from almost any angle, even if it's crooked or completely upside down. The position markers always set the frame correctly. Now look for a smaller square somewhere else in the grid. This is the alignment marker. It helps your camera read the code even if it's on a curved surface, like a coffee cup, or if you're viewing it from the side. It corrects for any distortion. You might also notice lines made of alternating black and white squares, often connecting the big corner markers. This is the timing pattern. It works like a ruler, telling the reading software exactly how big the grid is and where each individual square is located. The data itself, all the other little squares in the grid, make up the data area. This is where the website address, the password, or the contact information is stored. To understand how, think about how computers see the world. They don't see pictures or letters. They see everything in a language called binary. In this language, there are only two options, 1 and 0. For a QR code, a black square can represent a 1 and a white square can represent a 0. By arranging thousands of these black and white squares, you can write out any information in a way that a computer can understand. Your phone's camera quickly takes a snapshot of this pattern, and an app translates the grid of 1s and 0s back into the information you need. But here is where the design gets really clever. What happens if the code is smudged or a small piece is torn off? QR codes were designed for the real world, where things get messy. They have a built-in superpower called error correction. When a QR code is created, some of the data is stored twice, but in a very special, scrambled way. This means that if a part of the code is unreadable, the software can use the backup data to mathematically rebuild what's missing. It's like having a book with a few duplicate paragraphs. If one page gets a coffee stain, you can still figure out the complete story from the other parts. So a QR code isn't just a jumble of pixels. It's a highly efficient, self-contained information system. It uses simple, bold markers to guide the camera, making it fast and easy to scan from any angle. It stores information using the fundamental language of all computers, binary code, packed into a two-dimensional grid. And, most importantly, it protects that information with a brilliant error correction system, making it tough and reliable for everyday use. The next time you scan a QR code, you'll know exactly what's happening in that split second. Your phone isn't just taking a picture. It's reading a digital language designed to be quick, powerful, and incredibly resilient. It shows us that behind the simplest things we use every day, you can often find the most amazing ideas.